started off today by taking another look at these rational numbers. And remember, we played the big one game last block, and we dealt with fractions and decimals and percents. And I asked you to start off by thinking about what do they all have in common that make them rational numbers. And remember, what they have in common is they all can be written as a fraction, because a rational number is a number that can be written as a fraction with the numerator and denominator as integers. And remember that the denominator can never be 0. You cannot divide by 0. It's impossible. And in math we call that undefined. So I asked you, how is 165 centimeters, my height, a rational number? And most of you saw, well, you just put it over 1. So as a rational number, it's 165 to 1. So then I said, driving to school, if I travel 6 kilometers in 0.25 hours, and you all looked at the clock and you realized that's 15 minutes, and my question was, how many kilometers would I travel in 1 hour? And you had some very good reasons for how you came up with this answer. And one of the best I heard was, in one group, one person said that there are 4 quarters in a whole hour, and each quarter is 6 kilometers. So I've got 4 of those, and 4 times 6 is 24 kilometers. So that means I would be traveling 24 kilometers per hour. And that's an example of a rate. And a rate is a special ratio because it's comparing two amounts that have different units. And in my travels, I'm comparing kilometers and hours. So it's just a special ratio in that the units are different. 24 kilometers per 1 hour. In the percussion section, Hyojin pounded out 1,110 beats in 60 seconds, and we wanted to figure out her rate per second. How many beats per second? And a lot of you knew that you divided, and it got you 18.5 beats per second, but some of you didn't know why. Well, I told you just to think of what you do when you simplify a fraction. If I wanted to get from 60 to 1, I would divide by 60 to get an equal amount out of 1. So what you do to the bottom, you do to the top, because I must do the same thing to keep this equivalent, because 60 over 60 is just another form of 1. If I divide by 1, it doesn't change anything. So I divide 1,110 by 60, and I get this rate per second of 18.5 beats. So mathematically, when you have per, like if I ask the question, how many beats per second is it? That's a hint that to find that rate, you divide all the beats by all the seconds. And that gives you that unit rate of 18.5 beats per second. Then one thing that we've been studying is the difference between measures and counts. So I said, tell from your reading, if you remembered, how is a measurement of your height in meters different than a count of people in the room right now? And my hint was, what can you do to a measure that you cannot do to a count? And the big idea is, it's a measure if you can break it into smaller pieces. If I'm counting the number of people in the room, and I count 1, 2, 3, 4 people, I can't break that down. There's 4 people, and that's it. But if I'm talking about my height of 165 centimeters, I can change that to a smaller unit. I can break it down into millimeters. I can break hours into minutes and seconds. I can break years into months or weeks or days. I can break a temperature into halves. I can have a half of a liter. I can break a liter into deciliters. So all of those are measures because they can be broken into smaller pieces. So I told you Helen has 2 braids. Each of them is 25 centimeters long, which is a count and which is a measure. And most of you knew that 2 was a count. You showed me in your fingers. The counting unit is braids, but 2 is the count, and the measure is the 25 centimeters, which you could break down into smaller parts. And then we did the guided example on page 18, and the one that gave most groups the most trouble was the comparison of the population of the U.S. to Iraq, and it said that there were 11.3 times as many people in the U.S. as there were in Iraq. And what that means is that there are 11.3 people in the United States for each 1 person in Iraq. So when you say 11.3 times, it means that for every 11 3/10 people in the U.S., there's 1 person in Iraq. And we know we can't have 3/10 of a person. So if you want to make this more sense with a real number of people, multiply this by 10, multiply this by 10, and we get 113 people
to 10. That means for every 113 people in the United States, there are 10 people in Iraq. And maybe you can picture that better. But that's an equal ratio to 11.3 to 1. Next, we talked about what does it mean to simplify a fraction in lowest terms. And all of you knew that you just divide these 12 and 18 all by 6 and you get 2/3. But a lot of you didn't know what it means to simplify a fraction in lowest terms. So we put 12 toothpicks on top and 18 toothpicks on the bottom, and we made a fraction, 12/18. And when you're dividing by 6, really think of encircling equal groups on the top and the bottom. And the biggest group I can encircle is 6 toothpicks and 6 toothpicks and 6 and 6 and 6. 2 6s is 12, 3 6s is 18. And now you can see I've got a ratio of 2 circled toothpicks on the top to 3 circled toothpicks on the bottom. And that's the ratio of 2 to 3. It acts just like the fraction 12/18, but it just has a different meaning. I've got 2 parts to 3 parts. And I wanted you to try to figure out why this number is not a rational number. We have repeating decimals that can be written as fractions, and terminating decimals that can be written as fractions, and decimals that are mixed numbers that can be written as fractions. But what was wrong with this number? And some of you figured it out. You can never find the denominator of the fraction because this pattern 0 1 0 0 1 0 0 0 1 0 0 0 0 1, I'm adding one more 0 between each one. That pattern continues infinitely. So I never know the place value to find my denominator. It's not tenths, it's not hundreds, it's not thousands, it's not 10,000s. This never ends. So I cannot write it as a fraction, so it's not rational. And there's a special name for not rational, and that's irrational. So that's an irrational number. We looked back at that Antonio's Barbershop newspaper article, and you had to find some rational numbers that were used as measures, and you did, 24 hours and 7 years. And then we need some rational numbers that were ratios. 50% is the ratio of 50 to 100, and there was another statement that something had 3 times as many as something else, and that's the ratio 3 to 1. So you did an excellent job with that. And then we looked very carefully about when you write out the name of a decimal, you have to be really careful to communicate effectively. This decimal in red is 900 thousandths. This decimal is 900 thousandths. And the only way you can tell the difference is the hyphen. So that hyphen is really important because it tells the place value of the 9. So be careful when you're writing. All right, then we had our showdown competition with your groups, and you had to put your heads together and answer this, and when you all agreed on the answers, you jumped up and shouted showdown, and then I just called on people at random in your group to make sure you all agreed. So the rate for this first example was 120 kilometers per hour. The rate unit is kilometers per hour, and a different ratio that it would equal could be 240 kilometers in 2 hours. In fact, there are infinite ratios. We can triple 120 in 1, we can quadruple 120 in 1, and we'll continue getting equal ratios to 120 kilometers per hour. Okay, the second showdown. The rate was 22.4 students per class. The unit was students per class. A different ratio that it could equal, well, you can multiply your 22.4 over 1 each by 10, and you get 224 students per 10 classes, and then you can divide each of these by 2, and you could have 112 students for 5 classes, or an infinite amount of other possibilities. In a European town, there were 5 times as many voters in 2012 than 2011. The ratio was 5 to 1. Another easy equivalent fraction was 10 to 2, and what was being compared were the voters. All right, I gave you back your quizzes. Remember, you can retake that after school, Friday, Monday, or Tuesday. If I wrote office hours in your planner, then you must see me during office hours on Monday and retake it. So the quiz is in your math binder, your red binder in the assessment section. Study it if you made some mistakes. Retake it if you want to get a better score. This is tonight's homework. It's also on Moodle, and here's a bonus question. So if you'd like to try that, use your laptop and the internet and figure out the euro to dollar ratio.